Here I have a rectangle ABCD where point A is 0, 8 and point B is 4, 0. The diagonal AC has the equation of 8y plus x is equal to 64, and I need to find the coordinates of C and D. So this is my rectangle, this is point A, this is point B, and I need to find the coordinates of point C and the coordinates of point D. So first let's calculate the coordinates of point C. Well, I know that point C is the point of intersection of this line and of this line. If I can solve the equations of these two lines simultaneously, then I can get the coordinates of point C. I already know the equation of line AC. Let's find the equation of BC. For equation of BC, I'm going to use the formula y minus y1 is equal to m times x minus x1. To use this formula, I need to know the gradient of line BC, and there's only one point which is known on this line. So I can't use the formula of the gradient to find the gradient BC directly, but what I can do over here is that I can use the fact that there is a 90-degree angle between these two lines, because I know that this is a rectangle, and in a rectangle all angles of the vertices are 90 degrees. And since there is a 90-degree angle here, I can say that the gradient of AB times the gradient of BC is equal to -1. I can find the gradient of AB using this formula of y2 minus y1 divided by x2 minus x1, because there are 2 points known over here. If I name this as x1 y1 and this as x2 y2, the gradient would be equal to 0 minus 8 divided by 4 minus 0, which is minus 8 upon 4, which is minus 2. So the gradient of line AB is equal to minus 2. So this would be equal to minus 2 times the gradient of line BC. It would be equal to -1. And dividing both sides by -2 would give me the gradient of line BC as +1 upon 2. So the gradient of this line is 1 upon 2. Now I already know a point on this line, that is point B. So I can go on and use this formula. This would be equal to y minus, the y coordinate is 0, so y minus 0 is equal to m, which is 1 upon 2 times x minus x1, so x minus 4. 1 upon 2 times x minus 4 is going to give me y is equal to 1 upon 2x minus 4 upon 2, which is 2. So this is the equation of line BC. Now for the coordinates of point C, I am going to solve this equation and the equation of line AC simultaneously. The equation of line AC is 8y plus x is equal to 64. Now solving these two by substitution, if this is equation 1 and this is equation 2, substituting equation 1 into equation 2 would give me 8 times 1 upon 2x minus 2 plus x is equal to 64. Multiplying these two brackets, I'll get 8 upon 2x minus 16 plus x is equal to 64. 8 upon 2 is 4. I'll get 4x minus 16 plus x is equal to 64. 4x plus x is 5x, and adding 16 on both sides would give me 64 plus 16, which is 80. And dividing 5 on both sides would give me x as 16. So the x coordinate of point C is 16. For the corresponding y coordinate, I am going to substitute this value of x in either one of these two equations. Equation 1 is more simpler, so I'll put this in equation 1. So 1 upon 2 times 16 minus 2, and I'll get y is equal to 8 minus 2, which is 6. So the y coordinate is 6. So these are the coordinates of point C. Now let's find the coordinates of point D. Now for coordinates of point D, I know that point D is the point of intersection of line AD and line CD. So if I can solve the equation of line AD and the equation of line CD, Simultaneously, I'll get the coordinates of point D. Let's first find the equation of line AD first. To find the equation first, I need to know the gradient. This is a rectangle, so opposite sides are parallel to each other. This line has a gradient 1/2, so the line parallel to this line is also going to have the gradient of 1/2. I already know a point on this line, that is 0, 8, so I know the gradient and the point on the line, so I can move on to find the equation, and the formula of equation is y minus y1 is equal to m times x minus x1. The y coordinate is 8, so y minus 8 is equal to m, which is 1/2 times x minus x1, so x minus 0. This would be y is equal to 1/2x plus 8. This is the equation of line AD. Now let's find the equation of line CD. I know that these two lines are parallel to each other. This line has the gradient of -2, so this line is also going to have the gradient of -2. And I already know a point on this line, that is 16, 6. So now I can find the equation. The formula of equation is y minus y1 is equal to m times x minus x1. Putting these values would give me y minus, the y coordinate is 6, so y minus 6 is equal to m, which is -2, times x minus x1. The x coordinate is 16, so x minus 16. This would give me y minus 6 is equal to -2x plus 32, and adding 6 on both sides would give me y is equal to -2x plus 38. This is the equation of line CD. Now we're going to solve these two equations simultaneously. Y is already a subject in both of these equations, so substituting y of this equation into this equation would give me 1/2x plus 8 is equal to -2x plus 38. Shifting the terms with x on one side and the terms without x on the other side would give me 1/2x plus 2x is equal to -8 plus 38. This would give me 1/2x plus 2x is going to give me 5/2x, and -8 plus 38 is going to give me 30. Solving this equation for x would give me 30 times 2 divided by 5, which is equal to 12. So the x coordinate of point D is 12. And for the corresponding y coordinate, I am going to substitute this 12 into either one of these two equations. Let's just substitute it in this equation. So y would be equal to -2 times 12 plus 38. -2 times 12 is -24. So -24 plus 38, which is equal to 14. So the y coordinate is 14. So this is my answer. We have found both the coordinates of point C and the coordinates of point D. This is my answer.